Hey guys, welcome to day 3 of Trig review. Today we are going to review some actual trigonometry. We're going back to the SOH-CAH-TOA stuff that we learned back in geometry. So we can use these sine, cosine, and tangent trig ratios to find missing sides and angles of right triangles. And that's what this SOH-CAH-TOA acronym is for. It reminds us what order things go in, which trig ratio to use depending on which information we have, and that kind of thing. So it's important to note that when you are looking at a triangle, the location of the adjacent, hypotenuse, and opposite sides change as per where the angle is. I guess not the hypotenuse really, that one's always going to stay constant, but the opposite and adjacent depend on where the angle is. So let's take a look at some examples so we can see how this is done. Alright, so this first problem here, we have a right triangle with a 37-degree angle, and we have some information about it. So the first thing we want to do for these kinds of problems is label the sides where there's information as O, A, or H. So this 8 over here, we know it's the longest side on this triangle, so we're going to go ahead and label it H for hypotenuse. This B is the one that's right next to the angle, and so that's going to make it the adjacent. Now adjacent literally means right next to, and so you should be able to tell which one's adjacent versus opposite, because opposite is always the farthest away from the angle. If you look up here, this side opposite, it's all the way on the other end. It's not even touching the angle. Okay, adjacent on the other hand is touching the angle. So as long as you don't confuse it with the hypotenuse, that should be a helpful trick. Alright, so now I labeled A and H. It's true that this side would be labeled O because it is the farthest away. However, I'm going to go ahead and ignore it because I don't have any information about that side, right? They didn't give me any numbers or anything here, so it's not useful to me to label it. So just looking at this, I see that I'm working with A and H, adjacent and a hypotenuse. So I go back up here to my little key and I ask myself, okay, which trig ratio uses adjacent and hypotenuse? Is it sine, is it cosine, or is it tangent? And hopefully you would notice that cosine is the one that uses adjacent and hypotenuse. So I'm going to go ahead and set up my proportion here, and I'm going to say cosine of the angle. It's always of the angle. Let's try that again. Over 1, and then equals, it was adjacent over hypotenuse. So that's exactly how I'm going to set up my proportion. I'm going to do my A, which is that letter, we don't know it, and then my hypotenuse is 8. So now that I've set up my proportion, I'm ready to cross multiply and solve for my variables. So this is going to be one diagonal, and this is going to be my other. So now B times 1 just equals B. And then 8 times the cosine of 37, well, we don't actually know what that equals, and this is when we have to get our calculators. So the first thing you want to do is make sure that your calculator is on degree mode. So if you just go to this button and press that, it should say mode here. You scroll down to where it says radian and degree. You should be highlighted on degree mode, and I'll make this bigger so you can see. Right here, this degree word should be highlighted. Always check that to make sure that you're in the right mode, otherwise you will just get the wrong answer even if you do all the right things. Alright, so we're going to go ahead and type in what we see here. So 8 cosine of 37, that's just 8 times cosine of 37. And we get an answer of 6.39, we'll say. So our answer is, about 6.39. Alright, so let's try the next one. Same first step, we start by labeling our sides. So X is the farthest away from 38, this angle, and so if we drew an arrow straight out of the angle, it would land on the side that's the opposite. So this is going to be our O. 12, you should be able to tell, is the hypotenuse, it's the longest, and so we know we're working with O and H. So we scroll up and we're like, okay, which one of these is O and H, or opposite and hypotenuse? It's sine, right? Opposite over hypotenuse goes with sine, so we will go ahead and say that the sine of 38 over 1 equals opposite over hypotenuse. So for me, that's x over 12. So let's go ahead and do our cross multiplication thing. So we get 12 sine 38 from the first diagonal, and the second one, x times 1 just equals x. So this is where you have to type into your calculator again. We'll just calculate 12 sine 38. And we get 7.39. It's really an ugly 7. All right, one more here. Same starting, so let's go ahead and label our sides. X is the farthest away from the angle. It's not even touching the angle, which means it's going to be the opposite side. And 12 is touching the angle, but it certainly is not the longest side like this one is. So this is going to be our A. And we scroll up to our key and we say, okay, which one of these is O and A? Tangent is the one that operates with O and A for opposite and adjacent. So we will use tangent. So we'll say tangent of 42 over 1 equals x over 12. Now, you don't always have to actually put this over 1. I just teach it like that because that's how I teach it in geometry, and typically people really are good with cross multiplying. So making it into a fraction gives you the ability to cross multiply, but if you prefer to solve it without that denominator of 1, it's totally fine with me as well. So we get the first diagonal is x times 1 equals x, and then the second diagonal is 12 times the tangent of 42. It does not matter which diagonal you write first. I know I've switched it off each time here. It really doesn't matter. So let's type this in. 12 times the tangent of 42. And I get 10.80. All right, so that is how you find missing sides of right triangles when you have two of them using right triangle trig. So the next thing we're going to learn, well, really just like refresh, because you did learn this in geometry, is how to find missing angles using SOH-CAH-TOA. Now, this one, in my opinion, is actually a little bit easier. So we still use the same ratios and the same labeling technique. So for this one, we're trying to find the missing angle. That's when we use inverse trig. And you'll see what I mean by that exactly, but we still start the same way. So we label our sides. This 13 is the longest, it's the hypotenuse, so that's going to be H. 12 is right next to the angle in question, so that's going to be A. This symbol right here, that's a theta. It's a Greek letter, and it's what math people just typically use for angles. It's the same thing as like an X or a Y, but we just use theta. So now that I have labeled A and H, I scroll up and I'm like, okay, well, cosine is the one using adjacent and hypotenuse. So because I'm looking for the angle, I'm just going to need to do the inverse cosine, not the regular cosine, but the inverse. So cosine is A over H, so I'm just going to do my A over H. Okay, and then this is something you just type into your calculator. So to access inverse trig, all you have to do is press the second button, and then you press your cosine. So you see there's like a little blue cosine inverse there. That's how you access it. So then you just type what you see, cosine inverse of 12 over 13, and I get an angle of about 22.6. So I will say that my theta is about 22.6 degrees. So I just solved for what this angle must be. All right, let's do another one. We have theta up here this time. It's very important that you pay attention to where theta is. It won't always be here, which is where your brain might just like assume it is. So let's see, 80 is very far from theta, so we're going to call that O. It's not even touching the angle. 18 is right next to theta, but it's not the hypotenuse, so it's going to be the adjacent. So now that we know we're working with O and A, we look over here and we know tangent is the one with O and A. So we'll set up a tangent inverse of O over A. And you type that in your calculator. over 18. And we get 77.3. All right. And one more example. So this time theta is back over here, and let's go ahead and label. So 42 is the farthest away, so it's going to be the opposite. 58 is the longest, that's going to be hypotenuse. So we scroll up. Who uses opposite and hypotenuse? Well, it is sine. Okay, so we will say sine inverse then of opposite over hypotenuse, which in my case is 42 over 58. And you type that in. All right, and we get 46.4. So my angle is about 46.4 degrees. All right, go ahead and give the open math problems a try and let me know if you need any help.